torque is inverse to the degree of reduction or increase, because what happens with an increase in speed is a reduction in torque. So here, if you have the input really far away from the fulcrum and your output really close to the fulcrum, you move up on the input a little bit, or you move on the input a lot, and the output doesn't move very much. Because if you think about it like a seesaw, the way first class levers work, if you have a seesaw like this and you put your little input here, you'll get a huge, oh sorry, this is wrong. So you have your input really far away from the fulcrum, right? Like that. You move a lot here, and you get a little movement here, right? Because then as this moves, you still only have that little bit sticking out here, but now that there. So you see the amount that this lever moved when we push down, and the little amount this lever moved up. Because torque is inverse to motion, if you think about it like this. So your second reverse gear example, the fulcrum was really close to the input. So let's move our input here. Now we push down, and the output moves a lot further, right? Like that. So, but if you push down, but then remember, torque is a function of force over distance. There's a big distance here and a little distance here. So, so this force is going to be harder to lift from this side, but it will move further for the amount that this moves. Now, when we're looking at forward gears, we're looking at class 2 and 3 levers. So we have our fulcrum is always at the end, and we have our motion, right? And then in this case, we have our input and our output are really close together, right? Because here, our fulcrum is always our sun gear, or sorry, if we take our sun gear as our fulcrum, then to get between the sun gear and the planet, we have the radius of the sun gear and the radius of the planet, and so that is 2 radii. Between our planet and our ring gear, we have only 1 radius here. So these 2 are close together. And then if we were to invert that, with our fulcrum being our ring gear, then our planet would be the only radius between the input and the fulcrum, where here we have 2 radii between the input and the fulcrum. And so looking here, that would be like having an input. So there's our output and our input. So for a certain input here, we will get a bigger output, right? That's our torque reduction, or sorry, our torque a reduction in torque, an increase in motion. So actually, we would call it an overdrive, because then if we move it like that, the input has moved some, but the output has moved more. But then, if we move our input close to the fulcrum, i.e. where we make our fulcrum the ring gear, now our input is really close to the output, a little movement in the input gives a great amount of output through the sun gear. So then we look at our, so then we move it from a second class to a third class lever, and we go like this. Now we go here, and we go here. So you have a much smaller input is necessary to get a much larger movement in output. So if we go up at the same sort of rate, you see how little this one had to move to get a lot of movement here. Now, you would have much less torque because our output has a much greater, in the class 2 and 3, the distance that matters the most is the distance between your input and the fulcrum and the output in the fulcrum. So the further away your input is from the fulcrum, the greater the torque will be, because your force multiplied by this distance, because force times distance is torque, right? Let's just write this down. Force over a distance equals our torque, right? So we have our force times distance here. That's our torque value here. And then we have our output here. And then if force times distance, now look at this distance times the force. So you're seeing a reduction in torque because this here, your input, has less distance than your output has. So your input has less torque than your output is applying, if that makes sense. So that's where our overdrive gear is operating. Now here it's more extreme because force times distance is torque. So if our input is super close to the fulcrum here, we're going to have a tiny amount of force there. But then we do our calculation for our output. Our output is super far away from the fulcrum. Now force times distance is working against us in a much bigger way. So then, that's how a maximum would work, because this is a maximum gear overdrive. Maximum overdrive. So then this one would be our minimum, because we are getting the minimum amount of increase here. Here we're getting a maximum amount of height change, because the maximum and the minimum, you can think about it like the amount of increase in motion for a given input. Or a reduction would be the maximum of the maximum amount of torque increase compared to, or the maximum reduction in motion. So reduction is reduction in motion. An overdrive or an increase is an increase in motion. This is our biggest increase in motion, and this is our minimum increase in motion. Back to our reverse gears. This one is our maximum increase in motion, and this is our minimum increase in motion.